Hello. Welcome, everyone. I see people commenting in the chat, so welcome. All the hands up and wavings and whatnot. We congregated here, I think it's the right word, I don't know, to talk about Waku. And we would like to talk to you about Waku and how to develop with Waku specifically. So we have basically 3 parts to this workshop or a presentation today. First part will be by Danish from js-waku team about js-waku. Then second part will be about Zoltan from nwaku team about developing with nwaku and how things work on that front. And then I will conclude with some general ideas and tips of how to develop with Waku, how to use it. And we will also, all of us will probably show some examples, show some code. We will share some links to the repos and things like that. So that after this workshop, or rather a set of presentations, you will be able to go and develop something with Waku. I mean, fingers crossed that everything works. Anyway, thank you again for coming along, for watching later, whatever is going on with you. And I will pass it on to Danish, who will tell you more about js-waku and how to use it and how it works.
Thank you, Vaclav. Welcome, everyone, to this presentation on building decentralized apps with js-waku. My goal today is to walk you through a practical, step-by-step approach to building with Waku, building a decentralized, we'll be building a decentralized messaging app. We'll be using js-waku, which is a TypeScript implementation of the Waku v2 protocol, written primarily for browser environments. Waku is a protocol designed for peer-to-peer messaging, perfect for our case of decentralized applications. Instead of just discussing theory, we'll actually build a complete React messaging app. Sorry, I'm just reading a comment with video being out of sync with audio. I'll just go ahead. Instead of just discussing theory, we'll actually build an application. And by the end, you'll understand how to implement core decentralized features that Waku offers. Real-time push and retrieval of messages, history retrieval, and application-level encryptions. So we'll start with a clean, modern React project using White. But feel free to use whatever framework we want. White gives us a fast development experience and offers hot module replacement, which usually should be a good way to get started. TypeScript provides us type safety. Now, this foundation ensures that we have type safety, we catch errors before runtime, instead of just relying on plain JavaScript. And for each slide, we'll see a view code on GitHub link. And here, this is a public repository that I created with all of the stuff that we'll go through in the presentation being segregated into steps. So for initial setup, I already have this set up here. And let's actually cd into the first and run this. And this is just going to spin up our White plus React code base. Now, moving on, now we add the js-waku SDK to our project, and this is the core library that we will use. The key concept here is that the Waku Lite node is a lightweight implementation suitable for browsers, so it does not rely on relay like our service nodes. We connect to the default Bootstrap fleet that we've hosted, but we will learn in the future slides how we can actually not rely on this fleet and use our custom nodes. Moving forward, we just start the node and we wait for that node to connect. This is actually optional for now because we're bootstrapping our node. Similarly, for this, we can go to GitHub and check out at this step. And let's actually try to do that to Waku node. And we run that, and we should see information about our Waku network, Waku node trying to connect to the Waku network. Yeah, so here we see we are now connected to the Waku node. We're starting to find some peers. There are logs spinning up. And moving forward, this is actually this might seem like a small step, but it's crucial for a good user experience. So by default, each time the app starts, it generates a new peer ID for our Waku node. We implement persistent identity here by storing a seed in the local storage, and the seed generates the same private key each time the app starts. So we can choose to use a custom seed, which will uh, create the Waku node with a fixed peer ID. Moving on, here is how we define the message structure that we will use throughout our applications. We're using protocol buffers here for just efficient binary serializations. This makes our message a bit smaller and faster to process than JSON. So here we're defining a very simple schema. We have the timestamp of the message sent, the sender itself, and the message string. And down below, we create both encoders and decoders using our content topic. So think of content topic like channels in the Waku network. It determines who receives which message. Moving forward, we now set up basic UI components that essentially just stitches together all of the logic that we've built so far. Let's actually check this one out because we'll finally have some UI going. Yeah, so we now have this application where we now have an option to initialize our Waku node with a random seed or use our custom seed. And the node is not yet initialized, of course. So let's actually try to use a custom seed, initializing Waku node. Give this a second. We see some logs spinning up, and we have our application running. So this is what our structure for the app will look like. This is only step 4. We're only on step 4 so far. And some of the features we've made structure for here will be implemented in the later steps. But what we're looking for right now is that the peer ID here is being generated. We're connecting to 20 peers. And let's actually go ahead and try to also use a different seed. I forgot what peer ID it was. So we'll do this one more time, and we'll keep a track of the peer ID that it generated. So it ends with 27. And let's now use a completely different seed. Shouldn't end with 27. That's our only criteria. Awesome. It ends with TE. So safe to say we've been able to initialize our node. We have set up our encoders, decoders. We've defined a message structure that we will use in the next slide. Now comes the part where we actually use that message structure and send messages using light push. So light push enables clients, Waku light node clients, to send messages. Here, your browser Waku node uses a full service node, which is usually our nwaku, the NIM implementation of the Waku node, or the Golang implementation of the Waku node that's running. And light push essentially sends this to the full service node, which proxies the light client's request and sends the message into the network using relay. This is perfect for browser environments where the resources are limited. We serialize our message using protocol buffers, and we'll just send it through the network using the light push protocol. This implementation follows an asynchronous pattern with async await. and let's try this bit. So we want to go to light push and just start the server. This time I'll just initialize with a random seed. We are on the right step. And we now see an option to enter our name. This is a test message from the Waku workshop. And we don't have a filter implemented yet, but ideally in the next step, we should see this message popping up in the filter um, tab. And just as a side note, we'll also talk about it in the later slides. We'll see a lot of logs here, a lot of errors, but this is common. This is nothing to be worried about. Moving forward to actually receiving these messages with filters. So to receive messages, we're going to use Waku's filter protocol. Filter allows clients to subscribe to specific content topics. When a message arrives, we deserialize it from the binary back to our message format. And we use React State to store and display the messages as they arrive. The subscription patterns use callbacks to process each incoming message. And this is the actual callback that we're passing to the filter subscribe. And yeah, we can handle errors here. Let's see how that works. That's going to be 6. Okay, cool. We have 3 connected peers, 4, and let's try to send a message. Hey, this is a test message. All right, that did work. Okay, awesome. So yeah, there's a duplicacy here, but this is essentially how our messages will start to flow in, and they just seem to keep coming in. But we get the functionality that we're talking about here. Note that this was actually an application layer that is making the message render again. This is fixable on application layer, and perhaps by the time you're watching this, this will be fixed on the actual GitHub code base. Moving forward, what if a user joins the chat after messages were already sent? So filter and light push allow us to, in real time, send and receive messages. But as we saw, we had already sent some messages in the past that were not retrieved. This is where store comes in. And we just start with the node.store, waku.store, we access store, and then there are a couple of query methods available, but this is one of the more straightforward ones where we pass the decoder that we expect to be used, and there's a callback attached to process the Waku message. So we decode the message and then we do whatever, which in our case is going to be rendering it in our retrieved messages tab. We can also go ahead and use some pagination, set some time-based filtering, and the type for this also comes from Waku SDK. So feel free to just command click onto the type to view what all we can specify. Let's actually test store before we move forward. Just ensuring we're running on time. Cool. We initialized our node. Waiting for, so we see this particular log, which essentially waits for the node to connect over store. And seems like we are connected to a decent number of peers. Now this button here will load our history for our particular content topic. No messages yet. That is not true. So we do see store working well on the logs. Awesome. So yeah, these were some of the messages I sent over today, and this is marked with the store flag, so we know how to distinguish between the messages that are live received from filter and the messages that we received over store. Moving forward, encryptions. So privacy is a core feature of many decentralized apps. We implement two types. We offer two types of encryptions: asymmetric, using a public and private key pair using SEs, ECIES, and symmetric, shared key based encryption. So asymmetric is great for direct messages between known users. Um, Symmetric works well for group chats where everyone perhaps has the same key, and where you just import uh, this actually gets imported from message encryption, so Waku/message encryption instead of SDK. This will also be fixed by the time you get onto trying this. But yeah, so you import these methods, and we create a new encoder from our SES library and pass it our content topic and the public key. Similar for the decoder, and we use these encoders and decoders the same way we used them for plain text sending and receiving. Similarly, for symmetric key encryption, we import this also from Waku/message encryption, not from SDK, or maybe it is re-exported. We'll have to double check on that. We create a symmetric key. We create an encoder for that symmetric key and also a decoder. And just as all of these steps and their code bases will be attached. I'll share them in the comments and will be attached somewhere in the description or somewhere down below. But for now, let's just see how it looks, how we use them. So yeah, let's wait for this to get initialized. And we see this little toggle here down below. So by default, every message that we're sending is unencrypted and also receiving. So our decoder, if it receives an encrypted message, will not be able to process an encrypted message because we do not have access to the key we want to use to decrypt it. So we enable it and we see two options. We can use asymmetric or symmetric. And there's a little steps written down below here to just ensure. So the idea is we generate our own key. Now we export it because we want to paste it in a separate browser. For the scope of this presentation, I'll just not do that. And you wanna actually do this. We generate our keys here, we export it so it's copied to our clipboard, and the idea is we'll paste this key in our peers tab. And here we paste the hex key for this peer, and this is imported. Perfect. This is ready to use, but also we want to export this key and import it here. Right now we're ready to use, we're encrypted with SEs. And the other sort of encryption that we can try here is symmetric. So we generate our key and we export it. Similarly, we import it in other tabs. So we're getting very close where we're mostly done with discussing what all we can do. But one important detail throughout building the application is going to be how do we debug things, right? We implement a very simple toggle for now within our UI that just enables Waku logs in the background that you were probably seeing through my screen share. And all it does is just like sets a key value in the local storage. We use debug and then just Waku star. So we're essentially printing all Waku related logs. And these are segregated with info and error. So feel free to do something like Waku. So feel free to do something like Waku star info and then star so that you only capture info based logs, or similarly for error, we can do that. And we have we've done a simple toggle so that you don't have to worry about this, or at least don't worry about setting it in local storage manually. One important thing I would like to highlight is I had Honey installed as an extension, and it would always override my debug the debug key in my local storage. So make sure none of your extensions are overwriting local storage. So I do have it enabled here, and we see this little toggle. And just to verify, yeah, so we see Waku info based logs. If I do disable it, it will reload because local storage needs to um, it needs to fetch it from local storage again. And yeah, we don't really see any Vaku based logs. All of these logs are just console logs and console infos within my application. And let's see, let's just enable it again, initialize, and we start to see Vaku info based logs. We'll also probably see some Vaku errors. If you actually, let's just try to filter Vaku error. So yeah, that is how we debug. And there's something we briefly touched upon, I think in the first or the second step, is to you're probably initializing Waku with the default bootstrap field. This refers to the fleet of nodes that we, as an organization or maybe independent contributors, have initialized. And the idea is your js-waku node needs at least one node to start finding more peers. And if you do want to run your own node and not rely on Bootstrap Fleet, or for whatever reason you want to try your own node, you define the multi-address, and Zoltan in his presentation will talk about how you will do this. But essentially, you do get a multi-address from the node, and we change default Bootstrap to false, and we pass these set of our own nodes as a value in the Bootstrap nodes key in our config. Or you could choose to have this true and also use this. So you also find nodes from the public fleet, and you use your own node. This is pretty much it for our presentation. The js-waku documentation is linked here, the protocol specs, and the full source code for the entire app that we built through this presentation. And one final look of how this, yeah, actually the ninth step was the Rust. So we've already seen how this application looks towards the end. Just as a last walkthrough, we have an option to generate our Vaku peer ID through a custom seed or initialize it with a random seed. Test seed, and let's initialize. Now starts to find some peers. This is our persistent peer ID. Here we can retrieve things from the store. Here we can send messages. Hey, from workshop. And yeah, we can enable encryption and enable disable debug logs. Awesome. This is pretty much it for me. Do we have any questions? We do have a few minutes left. I'm curious if we have any questions. Let me look at the comments tab. That is a widescreen. It's a 34-inch widescreen. Awesome. I don't see any questions coming in yet. I guess I'll wait a few more seconds. And if, in case you do find you have some questions, you end up playing around with this in the interim, we will have Q&A after every presentation. So we have 2 presentations left. So feel free to put your questions in. Ivan asks, is it mandatory to use seed in js-waku? No, Ivan, it's not mandatory. If you do not use a custom seed, it will initialize with the random seed, and we are storing it in our local storage. But ideally, you would want to use the same seed so that your libp2p peer ID stays consistent. If also, it's fine if you don't. It will just generate a new peer ID every time you start your Waku node. Awesome. If there are any questions, please feel free to reach out to us on Discord, as Sasha mentions, or I'll be here till the end of all our presentations. Thanks, everybody.
Hello, thanks, Danish. I'm Zoltan. I'm sharing my screen. Maybe
your screen disappeared. Will you
yeah.
Go and present again?
Just a minute.
Oh, there it is.
Okay, so thank you for being here for today. And I would like to guide you through all this similar stuff what Danish has mentioned, but from nwaku and Waku node point of view. But probably most of these terms will be familiar to you, but I think it's good to go through, and I would like to highlight what is Waku, what are the use cases we cover. Actually, we are covering a broad range of use cases, and I would like you to have some digest or to hack something with Waku. So what is Waku in short? And I will run through these slides because I also would like to have a short demo using Waku nodes. So I think all of you know it's Gossip Sub on Boost. And definitely we are permissionless, private, secure, off-chain, and decentralized. And we are adding additional protocol layers and features to the Gossip Sub. And definitely what also mentioned by Danish that for resource-restricted devices and use cases, we are providing request response protocols like push filter and store that enables us to limit the bandwidth and traffic on those devices, and yet they can have access to the network. We have DOS protection implemented with the rate limiting nullifier, and actually it limits messages per peer can send to the network per epoch. Definitely, we have a test network. We call it the Waku network. We got thousands of nodes there by very good operators from out of the world, which implements mostly all of these features we are working on and we are providing, even RLM. And of course, we have added peer discovery, different set of discovery, discrete 5, peer exchange, rendezvous, and DNS discovery. Mostly we are using discrete 5 in our fleets. Maybe I need to slideshow. It would be helpful. Yeah, and as I mentioned, we are trying to cover very wide range of use cases. So Waku is data agnostic, so we don't care about the payload. We just care about the size of the payload, which can be configured up to 1 megabyte. And actually, some networks can limit to a certain amount, like the Waku network can send maximum of 150K. And as you can see, on top of the Gossip Sub, Waku message defines another layer. Definitely, we added some metadata and other fields that operate the Waku network. Actually, mentioned by Danish, the content topic is a kind of flag on the message, which you can use to direct your message between two peers or two M to N peers, let's say. Okay, what defines a Waku network? As you know, Gossip Sub defines a network per topics, which mainly acts as a router of the messages and then can help the gossip sub network to organize itself. On top of it, Waku defines clusters and shards. Each network, we call it a cluster, and normally a Waku node supports one cluster, and can support many shards. This shard can really help scale the network. So a node can decide if it would like to support all the shards or several shards only on the network. In our current cases, normally we are supporting all the shards on the network for your info. And yeah, I mentioned content topics are really application usage. And yeah, what are the use cases we are covering? And when I'm saying use cases, I'm really talking about the type of application you would like to develop on top of Waku and what it needs. It really depends on what you would like to achieve and how you would like to interact with the network. And like, for example, the easiest and simplest, maybe not the best approach is to use REST API towards a proxy Waku node, which you own and you control. Then you are able to build up a sync client, issuing REST requests, HTTP requests towards that node, and operates on the network. Of course, this REST API is a little bit more. We are able to, as you will see, we are able to, let's say, manage our node and check its health and all the other stuff. We have covered already js-waku. If you want to be a web application which runs on a browser or Node.js level, then you are able to use that. Actually, that provides a much convenient way to access Waku network. And of course, we are providing libwaku with language bindings, which acts as a native approach to build application on top of Waku. What it does, it really embeds a Waku node into your application in process, I would say. And there you are able to control and configure that built-in node as you wish upon your needs or demands. So, and I would divide other options. We already covered edge node. I will flip edge node, as Danish mentioned, which means a light client in other terms. Actually, that utilizes request response protocols to have access to the network. That needs service nodes to be available on the network, and that service nodes will provide these services for the clients. These clients will not participate on the relay network, so thus it will be able to gain benefit of not having to traffic all the messages on the network, but able to select which messages they are interested in. Actually, this use case mostly very suitable for web applications and also mobile devices, for example. And of course, you are able to choose a full node, a relay node, where you have access to all the messages on the network. And of course, it's up to you on how you select your messages out of the stream, mostly based on your content topic. Okay, and how to run a node? There are a bunch of ways to run a node. We have really added a lot of options here. Actually, you can run it from the binary you have built from the source of nwaku, and also we are providing Docker images. Basically, those are just preset pre-built images of our nwaku binary. And what we cover with the Waku Compose, it's really a preset set of tools with a node combined, and that's preset for the Waku network mainly. Of course, you can tweak that Waku Compose setup, and therefore you are able to utilize it in other fleets and other networks, or you would like to set up for your own network. It covers all the services. I mean, it provides all the services we have. We have these like protocols, like push, filter, and store. It also can store messages, and you are able to retrieve these messages via store queries. And I would like to mention here slightly a Waku simulator, which we are using mostly for testing, but I would really, if I would develop on top of Waku any application, maybe I would like to simulate a complete network just to be able to tackle all different scenarios my application, my client should work with and be prepared for. So, and that Waku simulator really has all the features. It can simulate the alarm, so the DOS protection. Of course, you are able to tweak it. Tweaking in terms of you need to maybe to touch the configuration and how it sets up the node. And of course, it has various options to attach nodes from outside to the Waku simulator. We have a very good documentation for this, thanks to Tanya. And yet, an important question already asked by Danish to show you address of your node. As you see that sometime your client node, your edge node, must know a fixed proxy node which gives access to the network. Therefore, we need to know how to address it and how to access it. Waku uses a multi-address concept for Lippy2P. I wouldn't say too much about it. Definitely, its important part is how you access the node. For example, what protocol it can use, what are the ports it exposes for the Lippy2P protocols, and we have a unique peer ID generated on the fly, which identifies your node across all types of accesses, I would say. And there is an option, as Danish mentioned already, upon question as well, that we are able to give deterministic seed for generating this peer ID, and for the Waku node, it's called node key. Actually, you are able to generate a random seed, and you can use it as a fixed node key. Therefore, your peer ID will be always the same as soon as you are using this node key. How you get your address after you spin up your node? There are several ways. I will mention it too. If you enable the REST service on your Waku node, we will see how, you are able to query via a REST request the debug info endpoint, and it will list you the listening addresses and also the ENR record. And of course, sometimes we are using logs, and definitely if you are running a node, you will see extensive logging. And I would like to highlight here at the very beginning of your logs, there will be two the highlighted log lines, listening on and announcing addresses, which you can retrieve your peer ID and access, multi-address. Okay, and yeah, configuring a node, it's even hard for us as well. Definitely, we had lots of options, and these options are necessary to be able to that flexible and provide that amount of use case coverage with our nodes. So the cluster ID is important because when you are defining a network, you must use the same cluster ID for all the nodes participating on that network. Cluster ID 1 is reserved to the TBN, and definitely it hides a bunch of preset configuration options, which are really for the Waku network. So if you are would like to have a node running on the Waku network, you just need to define cluster ID equals 1, and you will get all the necessary configuration. And of course, shards, as I already mentioned, you should list all the shards you would like to support with your node. Definitely, you must know somehow the network shards, the network supported shards, before you set up the node. Okay, and yeah, if there are several other options for setting up WebSocket support, which will be important if you are working with js-waku. And I would recommend let the log level at info. It will be enough logs for just to know what is happening with your node. I would highlight the not option. It is important if you are running. Most of us are running behind the network. Okay. Yeah. For operating a node, we must provide services. Definitely, you are able to switch on and off some features. Relay is a default option, default feature, and it's always on. And you are explicitly say not to participate on the relay network if you say relay to false. And if you would like to support other request response protocols, then you should be explicitly say write push or filter or store to mount those protocols. Of course, if you are supporting store, you must define access to a PostgreSQL DB somewhere. If you are plan to provide a proxy node to the network, I would highlight that you must switch on relay, definitely, because otherwise these proxy protocols will not work. And yes, there is a tiny part probably we will change in the close future, because for the client part of the light protocols, request response protocols, are always mounted, except filter. For the filter, you must define a service node which will proxy, which will serve you the filter service and will, let's say, filter the network for your messages, and you can, your client will get the messages via a filter push operation. So that's a little bit of hinge. I already mentioned about REST API. It must be set to true if you would like to set up a REST server inside your process. It's not mandatory, and it's not always necessary. For development purposes, I believe it's very helpful because you are able to dog food your application maybe, and also you are able to control your nodes. And last but not least, you must set up some kind of discovery in order to gain access to the nodes of the network. Mostly we are using bootstrap nodes on our normal fleets, on our fleets, which are fixed nodes on our appliances, and therefore we are able to set a fixed DNR to them, and that will serve us with the discovery feature, and will provide us already discovered nodes. It doesn't mention. I haven't mentioned here, but there is also a possibility with an option with static nodes. You are able to list your own nodes statically, so you don't need to discover them. You are just configuring as a fixed entities. And yeah, going forward a bit, how to check your node. I already mentioned REST API is a handful tool for that. We got lots of good endpoints, which we are using normally for development also, and I recommend to our operators to familiar with to be able to look at their nodes. Of course, health check is a common one. Usually, it's important when you're starting up a node and you are not, it doesn't answer, that you can check your node if it's ready for operation. If it's a node has ready, then you can be sure that your node up is up and running. Debug info you will be able to retrieve your node's addresses and version of your node, and what is important, you are able to examine the peers your node has already connected with, and also it lists you what are the supported protocols they provide. It can be important because sometimes if you feel that for example, a filter doesn't provide you any result, or there's some error, that you might want to check whether your node has relevant service node which provides filter service, for example. You can determine with this option. And of course, we are able to check logs all the time. If you are running the binary or a single Docker image, you will get it instantly in your terminal. And with Docker Compose, I think most of us are familiar with, you are able to check logs with compose logs, -f and nwaku. Also, if you are running several nodes, you might want to use ---index also for checking a single node logs. Yes, some keywords are already listed. Listening on an announcing address, you are able to grab for maybe, and also this node setup complete means your node setup finished and it's up and running, and will participate in the network. It can be important if you would like to track what is happening with your message in the network, for example, inside your proxy node, or if you are running, for example, a Waku simulator network, then you have access to all the logs of all the nodes. We are logging extensively message hashes, which are unique to each messages. So when you are inserting a message to the network, you should be able to see the first injection of the message into the network, and it will print your message hash to that message. And with that message hash, you can grab grab the logs for that message hash in the logs, and you will be able to see whether it's stuck somewhere or it has some problem with it or not. And of course, we have Grafana dashboards. We are validating our features mostly with metrics and verifying those as well. And we have very detailed dashboards available. The easiest to work with is if you are running a node with Waku Compose, then it has all the features bound together with Prometheus and Grafana. So you will be able to go to this address, localhost 3000, and have access to the monitoring of the Waku node. Also, Waku Simulator has its own dashboards, which gave access to all the nodes on the simulated fleet. And also, we have our infra hosted dashboards for our nodes, our internal fleets we are using for status and also for test networks. Likewise, I extracted the very first few panels for you. We are usually checking these numbers and graphs at the beginning, just to be able to see if the node is operating well or not. As you can see, we have connected peers, we have disk-5 retrieve peers, and we still have even more peers in our peer store discovered. And of course, it's very small letters, but we have connected peers or pair shards, you can see. And of course, if you see some traffic on the network, that means that your node is relaying messages on the network. Okay, how to build with Waku? Let me check the time. Yeah, some time left. As I mentioned, you are able to build a thin client with REST API, and I would highlight that this REST API gives access to the raw protocols. It means it's not very developer friendly. You should be able to handle all the different errors and hurdles by yourself. So this is not the most convenient way to develop on Waku, but definitely possible. And to gain access to the messages, you need to poll your proxy node with REST API. We have a reference page available here. js-waku, I think we have covered. I wouldn't like to spend more time on it. Danish was much more better than me with this. And what I would like to highlight with libwaku, natively with C, C++, or with language bindings, you are able to build a complete Waku node into your application. Therefore, it's a very cool way to build app and participate on the Waku network. So currently, I want to highlight that Go bindings is really under heavy dogfooding at this moment because status app just ported to nwaku, but which is highly tested is relay and store with Go bindings. For Rust bindings, we got a bunch of examples thanks to Ivan, and which currently supports all the protocols Waku can provide. And also, there is a slight Python bindings available. I'm not sure at this moment that how mature is it. For developing with libwaku, some very important warnings for you if you like to go with and hack with libwaku. Due to the nature of meme, as it uses a garbage collector, it must run on its own thread. Therefore, libwaku will, when initializing, we start a separate thread, and all your requests will be put to that thread, transferred to that thread, and executed up there, which is so far so good. It doesn't bother any host language. But what you need to consider that we are using callbacks to give you access to results and messages. But those callbacks will run on the separate thread of the meme-owned thread. Therefore, you shouldn't be blocking that thread in your callbacks. You shouldn't do any extensive operations on the data, but rather move that data to your host application threads. And also, I would like to warn you not to throw any kind of exception on the callback in the callbacks, because it will be incompatible with nwaku. Okay, and of course, you are able to use Nim to build your application, and then you are able to use natively our nwaku implementation. Of course, I listed you the entry points to develop with Waku, and we are happy to help you if you have any questions in our Discord channels. Okay, I have to check if we have a few minutes left. I would like to give you a small demo, a really small demo on setting up and spinning up some Waku nodes. For the presentation, I have chosen to run a service node and a client node, and I will use REST API to show you some features. And the fleet I will be using is status staging at this moment, this was the most convenient for me to put this together. So first of all, I would like to run this horrible long command. Actually, it should be much better if it would be wrapped. But anyway, this is running a Docker based latest Waku build. And as you can see, I'm using a fixed node key, a fixed seed, in other terms, which will help me to determine the multi-address of this node to be able to connect the other node. Cluster ID 16 and the shard defines this status prod, status staging, fleet. I allowed REST API. I have added Bootstrap node, and it will provide light push filter services. And yes, shortly, just to let you show, actually, we will have announcing address here, and we should listening on. Address is listed here, and somewhere here we will have it's already received relay message, so it's already part of the network. Node setup complete. And on the other panel, I will spin up my client node. It's okay. I have to highlight that light push node and filter node is pointing to this service node on the other panel, and I switched off relay. Yeah, and I will let you. I have created a small Python application. We'll deploy it to Waku Compose probably pretty soon for convenient, and it can help you, let's say, dog food and test your node a bit. For example, I can see my node address and DNR. Also, to be able to show you something a little bit, I will first of all check whether this client node has any filter subscription on any kind of service node. And as it said, okay, you don't have any subscription. It is important to ping for the filter because to avoid any dangling nodes around, this filter subscription storage is cleaned up regularly. So let's subscribe to some pops up topic on the cluster ID 16 and with the 64 shards. And I have defined, let's say, artificial content topic. Yes, it says okay, so I have subscribed. I can check with the ping. Great, it says okay, I have subscription, live subscription. So when I say I have the command stored already, I can inject a message with this client node, utilizing the other node to the network with this light push command. And actually, I hope it says okay. So we should be able to handling light push request. As you can see, we have cached in the right time the logs, and as you can see that this is our pops up topic, and of course, as I mentioned, we have the message hash. And also, we should be able to track that this message is relayed. And sent relay message probably, this is, you can see that this message hash matches to the error. So the light push service is on action. It's relaying to the network. And okay, let's check with our filter. Of course, it's a little bit tricky. We are using the same client with the same service node, but it's for the ease of the setup. And then I would like to get filter message. Okay. I have to put a command. A bit of cheat from the other screen. And as you can see, I will check for content topic of the filter. And yes, we have the same message presented for us on top of filter. And let's see another option. Let's see if this client has store peers. We have a small statistics over the peers. And yes, there are 10 nodes on this fleet, on this network, providing us store feature. So let's hope we are able to get us our messages from some of these store, because the service node I have started spin up doesn't provide any store storage service. But we are able to query through our client node random store service. And let's see if we can have some answer. Okay, no, at the first it's not. Okay, for the second try, yes, we are able to see my message has been retrieved from the storage, from some of the storage in the feed. Yes, it's important to highlight, which I think js-waku covers by itself, that you shouldn't rely on one single service node if you are running an edge node or developing an edge node. You should be prepared for failures, and you should be prepared to be able to switch nodes. In the future, we are planning to provide these services with our SDK. Hopefully, it will be very helpful for all the application developers. Thank you for watching me, and that was my presentation. I would like to hear any questions if you have. In the meanwhile, I will need to go back and see if you have any questions. Okay, thank you for the listening. Okay, question. Do I need to register consider some bar with others? What do you mean conflicting? Actually, well, yes, it depends on, because if you have two separate networks for your own, or maybe some others has a similar cluster ID defined networks, but they are not discovering each other, you will not have any conflict. You can have conflict if they at some point they are able to discover each other, different network, and they are not providing the services for the same shards. I would say, from Waku point of view, if it's same cluster ID, it will operate on any level. Of course, there can be many circumstances like RLM and such things might not matching between the two networks. Okay. Can we use any root addresses? No. To connect with js-waku? No, you should use the WebSocket one. It is starts with /WS or WSS, as if it's secure or not secure. I hope it answers. Okay. Do I miss anything? If not, then thank you, and we'll hand over to Vaclav for the last presentation.
Hey again, everyone. So in this last section, I'll just drop some wisdom on you. Hopefully it will be useful. Thank you to Danish and Zoltan for very comprehensive deep dive into their particular implementations of Waku. I would like to kind of step back and look at developing dApps, specifically with Waku, obviously, from more wider perspective. And the things that I will talk about are mostly extracted from me hacking on something called Kwaku. You can access it at kwaku.app, which is a Q&A, simple Q&A platform, which uses Waku and Codex. And basically by developing that, I think I've learned a lot from how dApps should be developed or could be developed, rather than saying something is decentralized and then running a single database somewhere in AWS. So first topic I want to briefly touch on is architecture. If you ever did like a distributed systems architecture, I mean, in Web 2 world mostly, you have a lot of patterns there, right? But in Web 3, we don't really have these patterns, or at least they are not super publicized. Obviously, people come from Web 2, so they understand the Web 2 patterns, but then it tends to be slightly different when you're working with peer-to-peer networks. So the standard one that we all know is client-server, right? And I would say that is obvious. Like I have a server, all the clients connect to that one server. It knows everything about everyone, and it's amazing, very easy, very simple, very straightforward, but it's not very Web3, right? Because there is no peer-to-peer. I mean, the client communicates with server kind of through peer-to-peer, but they are not peers. They are different level, right? Then we have client-to-client communications. So that is basically how we can form a peer-to-peer network where all the clients are communicating with each other. You could have experienced that with WebRTC in your browser when you're doing some experimental kind of chat applications or video or audio communication applications. You would usually connect these participants via WebRTC. The problem is that if you form a full mesh, it's going to be very bandwidth heavy. But in any case, that's another option. So like communicating directly between the clients or the instances of an application. And then the last one is client to network, where I open an application on my laptop and I want to gather some information or publish some information, and I just randomly connect to any node in a network where there is a bunch of equally powerful nodes, and I pick one randomly or by some algorithm, and I connect to it and I talk to it, and then it disseminates the information across the whole network. I would say that the client-to-client and client-to-network are essentially similar. The difference is that in the client-to-client, there is generally like all the nodes are the same application, same implementation, or same protocol. With client-to-network, there may be additional protocols between those network nodes. There may be other architecture paradigms, and I would be happy to discuss that because I would like to create more comprehensive presentation at some point about this. So please reach out and let's talk. Now I've highlighted these two down there because I think that's where Waku or applications built on top of Waku fits in. If you build a client-server application and you use Waku, you're not actually gaining much. You're actually losing a lot because you suddenly have a lot of limitations like message size, bandwidth, hardware rate limiting, and all these things. So if your goal is to build a client server where there is one server and many clients, then do not use Waku. And I will discourage you from that on every solution architecting call that I go to. But if you're planning to build something that is, let's say, client to client, so maybe it's a local first, and you wanna exchange data directly between clients rather than going over a particular node, or if you want to do client to network, so we have set of network nodes like Waku does, but then from the application perspective, let's say like blockchain, where the nodes kind of talk to each other and then clients connect to particular nodes and gather information or disseminate information. That's where Waku could fit in very nicely. Second part of that is state, and it also kind of goes with the difference between Web 2 and Web 3, where in Web 2 your state is usually in a database, and then by connecting to the database or connecting to a service that has access to the database, you immediately have the full state. So that's what I call full distribution. If you are talking about this spreading state across Waku network or across applications connected, the full distribution would basically mean that the whole state of a particular identity of a particular application will be sent every time there is a change to that state. And that's kind of what you do with the database, right? Because you just say, oh, I would like to write this change, but then the node holds the whole state. That's problematic when you come to Waku, because if you're pushing the whole state of your application, let's say, since I'm talking about the Kwaku, or since I've been talking about Kwaku, if the whole Q&A, which can be hundreds of questions and answers and upvotes and all these things, is pushed with every single change, then it's a lot of bandwidth consumed without a lot of benefit. So the second option is event sourcing, and it's coming from Web 2. It's a design pattern where you basically, instead of pushing the whole state around, you push only updates to the states or modifications. And then the state is recomputed locally. That can be locally in your instance or locally in wherever that state is persisted on some network node. So you can see here that I have one event, and then based on that, I link it to another event, and I link it to another event. And at the end, I can reconstruct the whole state. That's how Kwaku works, by the way. When you publish a question, when you publish a Q&A, it kind of creates the initial Q&A event, and then every single question is just a follow-up on that and referencing that initial Q&A event, and then every upvote is referencing, is like an event that is referencing the question you're upvoting with some additional metadata. And then the last one could be that you still want to keep the state cohesive, because the problem with event sourcing is that if you miss some messages and you don't have a good algorithm or good protocol to make sure that you have all the messages, the state that people arrive to can be different. And one is about eventual consistency, so it just takes longer to load everything. But then also, even then, you may not be sure that you actually get everything. So this will be solved with Waku by introducing new protocol called SDS, and I always forget what that acronym means, but you can search for it. But SDS will help us to, when you use something like event sourcing, it will help us to make sure that you got all messages and that your state is actually recomputed from the valid event list. Now, the last one, the offload, what I mean is that if you really need to have a full-blown state somewhere, but you still want to share its reference and its kind of content, you could offload it to some external storage, some decentralized storage like IPFS, or ideally, from my perspective, Codex. And then you push it to the other network, which is made to host large objects. And then all you need to move around Waku is CID, which is a pointer, a content hash of that object. So every time you make a change, you can just upload it again to Codex, and you can push the CID around without actually worrying about the bandwidth on the Waku network itself. Sasha is commenting, SDS, scalable data sync. Yes, thank you very much. I just doesn't stick to my brain. And it will be in js-waku SDK soon. Yes, I'm really looking forward to that so that I can incorporate it into Kwaku. So these three options you have, and for smaller states, you can still use full distribution. Like if you're syncing something from one device to another and you just do it once in a while, that's fine. But if it's like every minute I need to publish this 100 kilobyte file, it does not sound like something that would be super awesome for Waku. Waku will handle it, but it's just not great architecture or approach. So I would look into event sourcing, and I would look into how you can offload data to some external storage and just push around CIDs. So for use cases, I've just listed some that are from top of my head as I was watching my colleagues' presentations, and I was like, well, what else that they didn't say I could add? Zoltan mentioned use cases. This is from slightly different angle. So I basically created a few slides on the go. So for use cases that when you start thinking about how should I use Waku, you can think about notifications. Your app starts, your clients connect to the network, and then you can get some latest information, right? So someone published something, someone upvoted something, someone uploaded a new content to a decentralized storage that you are interested in. So you could use Waku very easily for notifications. Signaling is an approach where you need to negotiate connection and maybe encryption between multiple participants so that they can connect directly. Let's say you require a high throughput, low latency connection between 2 or 3 people because they are going to play multiplayer game. I don't think that multiplayer games will ever come to Waku, at least not with like all the stuff like RLN and limitations of the Waku network. Maybe you can build a custom Waku network and it will be good enough for you. But for running on a global generalized network, I would not say like multiplayer gaming is a great use case. But you can still negotiate the connection between those players in the multiplayer setting through something we call signaling, and use Waku as a signaling network so that they don't have to leak privacy to everyone. They obviously leak some privacy to each other because they will have to connect to each other. But they can negotiate in a privacy and censorship-resistant setting over Waku. Danish is saying MPC, multi-party computing. Yes, absolutely. That's another one. I think we have already had it in like idea board and all these things, so I didn't list it here. But yes, you could use Waku to do multi-party computation where the computation itself will not be part of Waku, but the communication between those parties that need to compute something, like maybe some key, they can communicate over Waku, and that comes back to no infra, I would say. So I will say basically, I will skip to the second to last item, no infra. If you're building something where you know you will need a peer-to-peer network, but you don't know how to build a peer-to-peer network, or you don't know what specifics will it need to have, like if you don't 100% know the bandwidth or the number of users or the actual protocol and all these things, then you need something that already exists, and that's Waku. And you can piggyback off the existing infrastructure and just connect your application to Waku network. And as soon as they are all connected, they will kind of discover each other, or rather they will get the messages that they are subscribed to through the content of it. The automatic service discovery kind of plays into that as well, because sometimes you have very specialized service, like let's say an AI inference node, and you want other people to discover it. And one way you can go is that you encode the address of that node to, let's say, a smart contract or to a website, a plain text website. Great, but not great, because if that address changes, if there is a lot of changes, then the smart contract will just bloat the state unnecessarily, especially if it's not like 100% stable and unchangeable information. And then if it's just a website and it's not censorship resistant, then, well, it's not private either. Because you first need to query the website, and then you can pick one of those nodes. So then suddenly that website hosting that information knows about your IP. So here, for what I mean by service discovery, so if you are running AI inference node and you want to know, and there is a client that wants to connect to it, you can just publish on some predefined content topic some announcements of your node, and then everyone else who listens on that content topic or who filters for that content topic will see that announcement and can leverage your node potentially, right? So kind of an automatic service discovery. And then last but not least, I guess, is chat. You can build a chat. Well, we've seen Danish build a chat in this presentation, kind of. So But what I mean by that is that if you think about it, even nwaku, the Q&A, is a chat. It's just application forming a message and publishing it for others to see it and reply to it with upvotes, let's say. So I think one wisdom that I discovered is that everything is a chat in the end, because there are some participants, be that humans or machines, exchanging predefined messages, predefined or free-form messages, and reacting to each other message. So everything is a chat. I wanted to mention content topic because we've heard about them a lot in these two previous sections, but we have not really seen what a content topic looks like and how to form it. And I think it's important to build a good content topic schema if you want to have a good application and good protocol. So our content topics are, as it has been mentioned, for filtering. So pub subtopics, lower level, that you should not care about ever, are equal to shards, kind of, and they are for routing. So your message will be routed through a shard, through nodes that are subscribed to that shard. So you don't really care about that. You just want your message to be routed. What you care about is content topic. And the content topic is there for filtration. You need to be able to filter, excuse me, you need to be able to filter for messages that you actually care about, because all of the messages will eventually or ideally be encrypted by your application. And you don't want to attempt to decrypt completely everything that flows in the network. You want to try to decrypt only stuff that you assume, or at least can guess, that it's for you. So we've formed this schema for a content topic so that also we can automatically map it to a shard and it's consistent. So it's formed by an application name. That's an arbitrary application identifier. You can think of, for nwaku, I have nwaku as an application identifier. Then there is an application version, or it should be probably rather protocol version, as that's what you will probably change if you change your protocol or if you upgrade your protocol in your application. And those two are used to compute the shard that your application or your communication will fit into, right? So those should not change unless you know what you are doing, unless you do it on purpose. So pick them wisely. Next one is arbitrary identifier, or something I call, it probably has a different name, but I really just made this slide up. So I didn't look into the spec. So it probably has a different name, but I'm going to just call it arbitrary identifier. This is something to help you with filtering. So let's say if I have a nwaku content topic, the Q&A hash will be the arbitrary identifier that everyone interested in the Q&A will subscribe to. If you have a chat between two people, you can just take their identities. So let's say wallet addresses, hash them together, and that will be their arbitrary identifier for that content topic, where messages interesting to those two people will flow. Just make sure that always when you do this, when you like use an identity of a user or something in your content topic, make sure it's hashed so that it's not leaking a lot of privacy. And then encoding, you can do something like proto for protobuf or JSON. I use JSON because I'm lazy and I want to be able to visually inspect the messages easily. And I know people hate me for that, so I will move to protobuf eventually. But Danish is much better than me, so he used protobuf right away. But basically, this is an encoding which your messages will be encoded in by your application, so that other implementation of your protocol, other implementation of your application will be able to decode the message based on whatever is there. So you could use the same content topic to publish JSON and protobuf, but then your application needs to understand which one to take and how to decode it. And then I have a bunch of random recommendations, and we don't have much time, so I will run through these. If you have issues with connecting from js-waku or generally bootstrapping your node, check fleets.status.in. There is a list of nodes that we are running or that IFT is running. Basically, you can find both TCP and WebSocket addresses there, and you can check peer IDs and all these things. So check which node you are connected to or not, and which is failing and things like that. One node I have here, and I actually heard it mentioned by Sasha, and I heard it mentioned by your callbacks, and that's for bindings in case of Zoltan's presentation, and that's for js-waku callback for processing a message generally callbacks must not throw. They must not fail in a sense of actually breaking, because if you're doing, for example, store query in js-waku and your callback throws an exception, the processing will stop and you will lose all the queried messages. So it will look like there were no messages maybe, but there maybe it was just one that was malformed or something. So just make sure you handle that rather than throwing. When you're running a service node, please use static node key. If you need a lot of privacy and you want every single restart to have a new PRID, then sure, why not? But if you want to use your service node, like connect to it from js-waku, connect to it from some other nwaku node or something, use static node key, generate a node key, pass it on to the node so that the PRID, the multi-address, the whole multi-address stays the same. I say use Waku dispatcher. That is what I use in Kwaku. That is a simple library that I built to help me work with js-waku. It's got much better over time. I mean, js-waku got much better since I started using it, but I stick with the dispatcher. We are developing something called messaging API. You can see it in our roadmap. There is a link to the roadmap under the messaging API link. And I will happily drop dispatcher or delete dispatcher when messaging API exists, but for now it doesn't. So if you need to do retries for your store queries, if you need to regular store queries, if you want to have more flexibility with dispatching messages and things like that, take a look at Waku dispatcher. This is more focused on the hackathon we are running soon for our own team. So you can use Waku hook. I think Danish will have something better in his demo, so go there. This slide was not made on the fly. This was prepared slide, so that's why it's there. But since Danish has already prepared the repo, there will be probably a better solution than this one. And then Zoltan talked a bit about bindings. So Go bindings, Rust bindings. One thing to mention is that bindings do not work at this moment, which is March 14th of 2025. They do not work with the Waku network. But what I did is I've created this example with js-waku and bindings and nwaku compose, which allows you to relatively easily set up a custom network or custom cluster and run it and use it. So if you want to develop today using bindings, you cannot use the Waku network, but you can set up your own cluster ID or set up your own network. And that's the number 42. We've decided for the upcoming hackathon that we will set up a bunch of nodes on the cluster ID 42 with one shard, so that everyone can develop against that rather than Waku network, which has some issues due to some EIPs being merged into Sepolia and other things. But more to that maybe later. So I think that concludes all the slides that I have, and I'm happy to answer questions. I see a lot of messages, but not questions. So if there are questions, I'm happy to answer. Does Kwaku use only the default bootstrap or also have some custom nodes running? So I'm not sure if I deleted it, but I had one hard-coded node apart from default bootstrap that I ran. There is currently no way to add nodes. That's a good point. I should add it to the settings section so that you can rely on your node rather than default bootstrap. Right now it uses default bootstrap because it's relying on the Waku network. So it connects to the fleet, to the bootstrap nodes. It discovers other nodes, and even if the fleet is inaccessible or overloaded or something, you will, once you load Kwaku for the first time and discover some other nodes, you will still be able to connect to those other nodes. But right now, it does not really support it unless you run it locally, which you can do, just npm install, npm start, and then you can go to code, find the bootstrap nodes in constants and pass in your own nodes. Any recommendations to make a two-way light node communication more reliable? In some cases, the communication is only happening one way. What could be potential causes? Well, the two-way light node communication unreliable means that one of those nodes, it's either not publishing messages properly to the network or it's not getting messages properly. So Usually the problem is filter, where your node will be disconnected from the filter, from the service node, and will not reconnect, which should be fixed now with js-waku with the latest versions. And I know that Sasha said that next week there will be a new version released with some fixes, some additional fixes. But I have seen this very often, that filter just disconnects silently. That was one reason for Waku Dispatcher to exist, where it would check the connection and reconnect. That is removed now because it's part of js-waku. Improve communication between two light nodes. If filter fails, do regular store queries. Make sure you track when you received last message, and then just do a store query since that last message reception and processing. And that should give you, hopefully, all the missing messages. I don't think there is a good other way right now, apart from trusting js-waku, that it will have filter working 100% of the time. But I think that's up to js-waku. That's generally the case for the network to fail sometimes. But the do regular store queries. There are some comments, not questions. Danish is giving +1 for dispatcher. It's quite reliable. Yeah, that's what I just explained. It does regular store queries so that you don't miss messages. If you want to build with custom clustered ID, not TVN, don't forget to update your network config when initializing light node. Yes, I was actually gonna show. I don't know how much time I have. I'm probably over time, so I was gonna show it actually working, but just to show a few things. So, well, Danish mentioned, if you want to go with custom nodes, custom cluster ID, when you are calling create light node here, I'll make it slightly bigger. When you're calling create light node, make sure you set default bootstrap to false, and then you configure your network config as so. So cluster ID, whatever cluster ID you pick, and then shards, whatever shards you want to subscribe to. You can pass in the bootstrap nodes. In my case here, it's one bootstrap node. And then I think, I'm not sure if this is necessary, but js-waku is trying to use multiple nodes for publishing, for filter, for store queries. Not for store queries, for publishing and for filter. If you're only passing in one node and you're using custom cluster where there may not be other nodes, I would just make this one to make sure that it's not waiting. The js-waku is not waiting to be ready if there is no way to be ready with 3 nodes, if there are never 3 nodes. Yeah, so this repo, then the example js-waku custom cluster, then allow you to run a custom cluster with running a bootstrap node. Running a bootstrap node based on nwaku compose. There is a network 42 branch. You can change the cluster ID if you want to. You need to get the public multi-addresses for that node. Then you can set up a backend, which is based on the Waku Go bindings. I can just quickly run it here. There is also a branch network 42 for that, for my fork of that example. And then there is this web app. When you start it, it will look like this. You saw Danish's beautiful chat. I am not Danish. I am me, and I do UIs like this. So then you can just type some message and hit send, and we should, if it works, we should see the message to be received here. But it's possible that I've messed something up right now. So I'm not sure if it's actually connected and working, because I think it died because I killed it. Anyway, that repo should give you a good start for running your own cluster in case Waku Network does not work for you for whatever reason, if you are in rush. Otherwise, reach out to us and let us know why it doesn't work, and we want to fix it or let you know how to fix it. Thank you very much. I think that's all. there are other questions for other people. I don't know if you still want to have time because we are over time, but if you still have questions for Danish or Zoltan, we can probably bring them back and we can let them answer. Otherwise, please come to our Discord and ask questions there. We are there. We are trying to answer all the questions and all the queries. So please do come to our Discord. We are always looking for new people showing up there and telling us what they are building or what they would like to build. And that's it. Thank you very much.